Hello guys, and today I'm going to be playing some Universe Sandbox. It's the first game, or first video I've done of this, and I don't really know what to do for you guys, because I don't know what you guys want, or anything. So I'm just going to be looking around on this game, seeing what you can do, and yeah. So what you just saw was a supernova inside of a galaxy, which was pretty gigantic, saying that this is a galaxy the size of the Milky Way. Yeah, so let's just go look around, see what we can see. Yeah, I'll show you guys what colliding galaxies look like. I looked at this earlier and it's pretty cool to see. I mean, just think about this. This is like 1 million years per second. This is how slow galaxies actually go, or like combine. You know what I mean? In this simulation, they don't go together that well. It usually turns out to be just them all separating from each other and spreading out in all directions. This will be relatively what a galaxy collision would look like what the Andromeda will look like colliding with the Milky Way galaxy. And since the stars are so far apart, the likelihood of them actually hitting each other is very low. There will actually be some collisions, but not many. It's really cool looking at this from the middle. Yeah. This is usually what it turns out to be. Oh, looks like there's actually something else forming in the middle there. That hasn't happened to me yet, and I've done the simulation a few times. Let's speed it up a little bit. See what happens. We're at almost 7 million, 6.6 million years a second. Stars are combining in the center. This is actually looking really cool. It looks like they just separated, so it looks like this might just end up being what happens normally. They just separate and go out in all directions. That's bigger than it normally is, though. There's a black hole there. Is there a black hole there as well? Yep, there's two black holes. Black hole there and black hole there. That's cool. So yeah, that was a galaxy collision. Alright, so here I have loaded up a Saturn simulation, and I just thought it'd be cool to look at this and see all the moons. Well, not all the moons, but some of them. I mean, there's obviously not, what, 80 moons here? I want to add some Saturn-sized rings around Saturn, because there aren't any in this simulation. Is there? I mean, this is just one of them. This is very few rocks circling it. So I'm going to add a bunch until I go down in FPS quite a bit. So I'm at 20 FPS right now. And this is what it looks like. It's not even close to what it is in real life. I'm going to bring this down to a second per second. That's a little bit too slow. Let's do second per second. Let's do 1. Okay. Alright, so this is just 4 seconds per second. But I mean, this is how slow the rings move. I'm just gonna keep it still here for a little bit. And that's how slow the rings move around Saturn. You can see them moving very slightly around Saturn. Let's see what happens if we put a Jupiter ring around there. It just goes about right there. Now, let's see what happens whenever we launch, let's just launch Earth at the rings. Right there. Let's speed it up a little bit. So we're going at minutes per second. And the reason why I shot it over that way is because the gravity's more than likely going to pull it toward, or it will pull it toward Saturn. So yeah, this is 9 minutes per second. I mean, Earth's traveling 18 kilometers an hour. Wanna mess with the rings? Oh no, I just hit. Alright, well, now I know I've got to throw it a little bit further out. And probably a little bit faster too. If I know how to. Boom, out there. Let me increase the time a little bit. I'm going at 16 minutes per second. Let's see what Earth does to the rings. Now Saturn's heating up because of Earth hitting Saturn. Wow, that didn't really do all that much. Here, let's get a lot closer and launch Earth over there. Alright. I don't know how to launch any faster than this. Oh, there we go, okay. That's how you launch a lot faster. So let's just launch at 100 kilometers an hour. And then let's get over here and launch you. They just made a gigantic, like, tunnel looking thing over there. Oh, that looks like where Earth went, the other Earth went right there. Oh wow, this looks really cool from way back here. Alright, let's, you know what? Where is this planets? No, it's stars, planets. Let's launch Jupiter. Right there. Oh wow, okay. That went behind it. There. Let's see what happens. Oh my god. Okay, I'm gonna make that go a little bit slower. Let's add some more Saturn rings. And then now, power, launch. Let's go 20 planets, Jupiter. Let's see what happens. Wow. Jesus Christ. Okay, that is crazy looking. Yeah. Oh god. This animation looks cool. Alright. Oh my god. Okay, that's a lot of explosions. Alright, I'm gonna restart this and look at it from the surface of Earth. Oh my god. Imagine seeing that come up the horizon. Actually, I mean, it's going a little bit fast, but... Alright, so this is 9 seconds per second. Imagine just looking up and seeing that. That'd be insane. The moon looks pretty cool. Now let's speed it up again. So we're at 9 minutes per second. Oh, it's gonna collide with Earth. Yep, that definitely collided with Earth. Oh, that's... looks like it's coming right for us, or was. That looks relatively peaceful over there. Alright, now let's look what's happening in third person. Wow, man. This looks so cool. Alright, I'm gonna speed it up really fast and see what it looks like. Oh. Okay. We'll just go there and we'll see what happens once it's a stable system. So, I went ahead and went into the future 248 days, so like 2/3 of a year, pretty much. And this is what happened. There are, let's see how many orbits there are. And it's gonna be kind of difficult to count. But I mean, you can just look at it here. These are all the moons that are rotating around, or orbiting, not rotating. Well, yeah, they'd be rotating, but they're orbiting around Earth. There are some that are orbiting closely, and then some that are orbiting really far away. Like this one. Let's see what's on this one. There are... No, I don't know what I'm doing here, so... Okay, so 86% of this is iron, so there's probably a magnetosphere around it. And then there's silicates, 14%, 0% water, 0% organic, 0% hydrogen. It's obviously not supportive of life. Don't remember where you have to go to see what the percentage is that it's like Earth. Oh, Earth similarity, 0.002%. That's really unlikely. Life likelihood, 0%. That moon's really hot. Hot. Let's go see if we can find a moon that isn't scorching. This is Nixie. It's 0.00275% Earth similarity and 0% chance of supporting life. 90% silicates 90.9, and then 9.12% iron. Where's the moon that's around here? I don't see it. Where are you? No, it's not that one that I was looking for, but we can go look at this one. Oh, is this snow covered? No, that's the one we were just looking at, isn't it? Yeah, it is. Is that it? Yep, but it's on fire. So this one is about half and half of iron and silicate. Nothing like Earth though, still. Yeah. Oh, looks like one just got shot out of orbit. There's one less. So if I were to count, I'd say 1, 2, 3, 4, 5, 6. One just got shot out, so it looks like there's 7 in orbit right now. So 1, 2, 3, 4, 5, 6. 6 in orbit right now. Yeah. After like 50 some in orbit. Oh damn. Never mind, they're not shot out of orbit, they're just in view. So yeah. Like 10 or 12 in orbit of Earth. It's really far out. Yeah. This has been Universe Sandbox 2. Hope you guys enjoyed the video. If you want me to do anything, just put it in the comments and I will do it. Yeah, this game is full of stuff to do. Yeah, I will see you guys in the next video. Goodbye.